welcome you in the lecture series of Basics of Communication Engineering. It is second lecture of this series. In the previous lecture we have discussed about some introductory part of communication system. In this lecture we will discuss about elements of communication system. The outline of this lecture are: what is frequency and wavelength, and the elements of communication system, and after it we will discuss about fundamental limitations. And in the objective of this lecture you will able to explain different elements of communication system and the limitations of the communication system. So first of all we will start with the frequency and wavelength. In previous lecture, we have discussed about electromagnetic spectrum or frequency band and frequency and wavelength related formula, and we have discussed that lambda is c by f, where c is the speed of light 3 is to 10 is to the power 8 meter per second, and f is the used frequency. So this is the relation between frequency and wavelength. Frequency describes the number of waves or cycles occurs per unit time. It is also referred to as temporal frequency. So here the relation between frequency and period of the signal, it is basically 1 by t, means frequency is 1 by time period. Here you can see in 1 second there are two cycles are completed, first cycle and second cycle. So in 1 second two cycles are completed here. So the frequency is 2 hertz and the period is time period t is 1 by f, or you can say 1 by 2 second. So the time period means the time to complete one cycle, and it is 1 by 2 second, you can see here. If just like a newborn baby's heartbeat is at frequency of like 120 times per minute, so here you can see it will be 2 times per second. So here the frequency is 2 hertz and time period is interval between two beats is half second, and frequency is 2 hertz, and frequency is measured in hertz. The unit of frequency is hertz. Frequency is an important parameter used in science engineering to specify the rate of oscillatory and vibratory phenomena such as audio signals, sound, radio wave, and light. Here, the relation between frequency and time is 1 hertz. It is basically 1 second, means one cycle is completed in 1 second. So the frequency is 1 hertz and period is 1 second. 1 kilohertz, it means 10 is to the power minus 3 seconds, or you can say 1 kilohertz means 1000 cycles per second are completed. 1000 means you can say inverse of this 1000, it will be 10 is to the power minus 3 seconds. And 1 megahertz, it is equivalent to you can say in time period it is 1 microsecond, or 10 is to the power minus 6 second. 1 gigahertz, it is 1 nanosecond, or you can say 10 is to the power minus 9 second. 1 terahertz, it is the 1 picosecond, or you can say 10 is to the power minus 12 second. Here 10 is to the power minus 3 second means 1000 cycles are completed in 1 second. And so this is the relation between frequency and period. Now we are on the topic elements of the communication system. Irrespective of the form of communication system, is analog or digital, There are three basic elements of every communication system: transmitter, channel, and receiver. And this block diagram shows you the different elements of the communication system. The three basic elements are transmitter, channel, and receiver. Transmitter is located at one point in space. The receiver is located at some other point separated from the transmitter, and channel is the physical medium that connect the transmitter and receiver. So channel is the connection between transmitter and receiver. The purpose of transmitter is to convert the message signal produced by the source of information into a suitable form for the transmission over the channel. So here the source is the generator of the information, and it generates the message signal empty, and to make or to make suitable for the transmission purpose this signal empty, the transmitter converts this signal into the transmitted signal st. So empty is converted into the st for the purpose of transmission over the channel, and this transmitted signal is propagates along the channel, and this channel having some imperfection, noise, distortion, interfering signals originated from other sources are added to the channel output. So at the receiving end, I'm getting the corrupted version of the transmitted signal. So R is here the corrupted version of the transmitted signal ST. This is a corrupted version of the transmitted signal ST. The receiver accepts this corrupted signal RT and reconstruct a, a signal or estimated signal from the original message signal for the user purpose. So it extract the transmitted signal from this corrupted signal for the user, and the here channel is a medium such as coaxial cable, wire, coaxial cable, a waveguide, an optical fiber. So it can be anything, a radio link, or atmospheric link. So it can be anything. So, and every channel introduced some amount of transmission loss or attenuation. So the signal power progressively decreases with increase the distance between transmitter and receiver. Distortion in waveform caused by imperfect response of the system to the desired signal itself. Distortion can be reduced using equalizer at the receiver end. Interference may be due to the signals from human sources, other transmitter, power lines, machinery, switching circuits, etc. Here, noise refers to the random and unpredictable electrical signal produced by natural processes, both internal and external, to the system. And filtering can be used at the receiver side to reduce the noise. Here, first, I will discuss about the source of information. What are the sources of information here? So sources of information, some of the important source of information in communication system are speech, music, picture, and computer data. A source of information is basically a signal which carries information. A signal, is defined as the signal a single valued function of time xt. Here t is independent variable. That means every instant of time the signal has unique value. So at every instant of time the signal is having a unique value, and this is the representation of the signal or information. And signal can be classified as one-dimensional signal, two-dimensional signal, three-dimensional, and four-dimensional signal. One-dimensional means speech, music, computer data. Two-dimensional, picture, and three-dimensional, video data, and fourth dimensional, volume data over time. Let us discuss these sources one by one. First is speech. It is primarily method of human communication. Speech involves transfer of information from speaker to the listener, and the band of the frequencies considered to be essential for the speech communication is 300 to 3100 hertz, and this band is used for the commercial telephonic communication system. Another is music. Music signal originates from the instruments such as piano, violin, flutes, etc. The music signal is a bipolar signal and needs a bandwidth of about 15 kilohertz. So the channel bandwidth required for the transmission of music signal is much larger than that required for the transmission of the your speech signal, because in speech signal you will require only 300 to 3100 hertz, and but the bandwidth for the music it is 15 kilohertz. Now the third source of information is picture. Picture can be either static or dynamic. Example of a static picture is a picture sent by fax machine, and the dynamic picture is one produced on the TV. The TV camera produced a dynamic picture and picture tube reproduced it at the receiving end. This is also known as a video signal, and the bandwidth required for a video signal is basically you can say from 0 to 5 megahertz. And another is source of information is the computer data. Personal computers are used for email, exchange of software, and sharing of resources. The text transmitted by the computer is encoded using American Standard Code for Information Exchange (ASCII). ASCII code are using in the computer data transmission. The channels here can be of two types. Guided means wired channel, unguided means wireless channel. Guided channel, wired channel can be a twisted pair of cable or coaxial cable or optical fiber, and wireless can be radio wave, microwave, infrared, and visible light communication. Here if I go for again for the elements of the communication system, here as I told you the message signal is converted into the transmitted signal at the transmitter and for the purpose of transmission through the transmission medium. The message signal can be analog in nature or can be digital in nature. So from the source, the message signal that is generated empty, it can be analog or digital, and for the transmission purpose this signal is converted in maybe in digital form or analog form, the signal that is suitable for the medium. It can be electromagnetic, electrical, electronics, or optical in nature. So here the transmitted signal which I'm going to convert, it is the ST. So message signal MT is converted into the transmitted signal ST at the transmitter end. This conversion of message signal to transmitted signal. It has different approaches. The transmitter is using different approaches. Just like if the message signal may be digital and the transmitter signal may be analog or maybe digital. So there are different combinations are here. So just like the approaches are message signal, transmitter signal, and conversion approach. So we will discuss about these. If the message signal MT is continuous time analog signal, and I am going to convert this message signal into the transmitted signal ST for the transmission purpose, and this transmitted signal is continuous time analog signal again, but maybe with different frequency. So this conversion approach is basically known as analog modulation, just like amplitude modulation, frequency modulation, phase modulation. Now, if the message signal is continuous time analog signal and the transmitted signal is discrete time analog signal, here the signal is discrete in time, but it is still continuous in amplitude. And this type of approach or this type of conversion is basically known as a pulse modulation, just like pulse amplitude modulation and pulse width modulation (PWM). And if the message signal is digital and I'm going to convert this message signal into analog signal before the transmission, then this type of conversion approach is known as digital modulation. Just like amplitude shift keying, frequency shift keying, phase shift keying, and quadrature amplitude modulation. The message signal may be analog and the transmitted signal may be digital, and this type of conversion is known as encoding, just like pulse code modulation and delta modulation. There may be another thing, the message signal may be digital and transmitted signal is also may be digital, and this type of approach is also known as encoding. And here we will use known return to zero NRZ, RZ return to zero Manchester, alternate mark inversion. So these are different type of conversion approaches here. And now we will discuss about fundamental limitations. In communication system, two primary resources are transmitted power and channel bandwidth. The transmitted power is the average power of the transmitted signal. The channel bandwidth is defined as the bandwidth of frequencies allocated for the transmission of the message signal. A general system design objective is to use these two resources as efficiently as possible. The most common channels one resources may be considered more important than the other. So we can classify the communication channel as power limited or bandwidth limited. For example, telephone circuit is typically a band limited channel, whereas the space communication link or satellite channel is power limited. So you can say your wireless channel is power limited and your wired channel is band limited. Power limited because we cannot increase the signal energy or signal power beyond a certain limit because it may be harmful for the human. So wireless channel is known as power limited. Also, there are two general kinds of constraints when designing a communication system. One is the technological problems such as hardware availability, economic factors, federal regulations, and so on. And other is the physical limitations, the law of nature, the fundamental limitations of information transmission by electrical means, bandwidth, and noise. The concept of bandwidth apply to both signals and system. When a signal changes rapidly with time, its frequency, content, or spectrum extends over a wider range, and we say that signal has large bandwidth. Similarly, ability of a system to follow signal variations in reflected is reflected in its usable frequency response or transmission bandwidth. So there are two types of bandwidth, signal bandwidth and channel bandwidth. And for the purpose of transmission, we have to match the signal bandwidth with the transmission bandwidth for the purpose of transmission with very less distortion. So bandwidth is the difference between the upper and lower frequencies in continuous band of frequency and it is measured in hertz. So just like if you are having a composite signal means the signal which is the which is having uh, which is the combination of different sine waves. And if a signal having the lower frequency component is fl and higher frequency component fh, then the frequency band, it will be the difference between these two frequencies. So bandwidth of any signal or system, it may be the difference between higher frequency component and the lower frequency component. And 3 dB point here, this is the 3 dB point. Minus 3 dB is at the start of the attenuation. So this is the starting of the attenuation. So if you are having signal in this frequency range or in this frequency range, there will be much attenuation. So if the signal in this range, there may be less attenuation or maybe minimum attenuation. So 3 dB point is also known as half power point. That is reduction of 3 dB in magnitude or voltage. You can say voltage may be 70.7% of its maximum amplitude at this point. So at this point, the maximum amplitude is 70.7% of its maximum, or you can say 50% reduction in power. So there is, at this point, there is 50% reduction in the power, and this has been chosen as convenient way to identify the bandwidth. So this is the bandwidth of your system or your signal. Communication under real-time conditions require sufficient channel or transmission bandwidth to accommodate the signal spectrum. Otherwise, several distortion will occur. That is, bandwidth of several megahertz is needed for a TV video signal, while for voice signal it is approximately 3 kilohertz. For digital signal with R symbols per second, the bandwidth must be if it may be greater than equal to R by 2 if there is R symbol per second. So available bandwidth determines the maximum signal speed. The time required to transmit a given amount of information is inversely proportional to the bandwidth. And another important point that have to be keep in mind is the unavoidable presence of noise in communication system. Noise refers to unwanted waves that stands to disturb the transmission and processing of message signal in a communication system. The sources of noise may be internal or external to the system. A quantitative way to account is effect of noise is to introduce signal to noise ratio. So to find the effect or to check the effect of the noise, there is one parameter, that is signal to noise ratio, as a system parameter. This is the ratio of the average signal power to the average noise power at the receiver. It is expressed in dB basically. So the of the power ratio, that is, if SNR is 100, then the SNR in dB, it will be 10 log 10 100, or you can say it is 20 dB. And another point is from the information capacity theorem, we have the channel capacity is basically C channel bandwidth B into log 2 1 plus SNR bits per second, and it is defined as the maximum rate at which the information can be transmitted across the channel without error. So this is the end of this lecture. Here we have mainly discussed about elements of communication system. This was the lecture second of lecture series of basics of communication engineering. In the next lecture, I would like to discuss about evolution of communication system, types of communication system, and the goal of communication system designer. Till then, thanks for listening this lecture. Thank you.